You use the internet every day, but you rarely see the system carrying it. You see the screen, you see the application, you see the message arrive. But behind that simple interaction is an enormous physical network. Fiber, routers, data centers, exchanges, transmission systems, undersea cables, and thousands of interconnected facilities spread across the planet. The digital world feels invisible because the infrastructure is hidden from view. But it is not invisible, it is physical. And whoever understands that physical layer begins to see where digital power actually lives.
When you send a message across the world, the information does not simply disappear into a cloud. It travels. It moves through access networks, through fiber, through routers, through exchanges, through data centers, across long-distance infrastructure, and sometimes beneath entire oceans. A single digital action can depend on a chain of physical systems spanning thousands of kilometers. That is the first hidden principle of the internet. Data may be digital, but its journey is physical.
Here is one of the most surprising parts of the modern digital economy. A huge amount of global internet traffic crosses oceans through physical cables resting on the seabed. These are not science fiction, they are engineered infrastructure. Long strands of fiber enclosed inside protective layers, connecting distant regions of the world. They carry financial transactions, business communications, cloud services, video, search, AI traffic, and enormous volumes of information moving continuously between continents. The cloud has an ocean floor. But cables alone do not create a network. The real architecture emerges where those cables connect. Data centers, internet exchanges, network hubs, cloud infrastructure, long-distance fiber routes. These nodes determine how information moves. Some locations carry enormous concentrations of traffic. Some routes provide redundancy. Others become strategically important because alternatives are limited. This creates a hierarchy. The internet may look decentralized from the surface, but underneath it is an architecture of nodes, routes, connections, and dependencies.
We call it the cloud because the word makes the technology sound weightless. But the cloud is not weightless. It is buildings, servers, cooling systems, power infrastructure, fiber, network equipment, land, engineers, maintenance, and enormous amounts of capital. The cloud is simply the interface we use to access physical computing infrastructure somewhere else. And once you understand that, the economics become clearer. Whoever controls the physical infrastructure beneath the cloud can influence the digital systems built on top of it.
Artificial intelligence adds another layer to this system. AI models require enormous computational resources, but computation does not happen in isolation. Models need data. Applications need connectivity. Users need access. AI services need to communicate with databases, servers, cloud platforms, and other systems. As AI expands, the network underneath it becomes more important. More intelligence means more computation. More computation means more infrastructure. And more infrastructure means more data moving between increasingly powerful machines.
And this is where the hidden system becomes interesting. Not every route is equal. Some networks have alternatives, some do not. Some facilities can be replaced, others are difficult to replicate. Some connections are abundant, others become critical because geography, economics, or infrastructure limits the available alternatives. When traffic concentrates around a small number of pathways, those pathways become strategic, because a network is not defined only by how many connections it has. It is also defined where those connections can fail.
This is where connectivity becomes power. A company does not need to control every part of the internet to become strategically important. It may only need to control a critical layer, a major network, a data center ecosystem, a cloud platform, a key exchange point, a critical route. The leverage comes from dependency. When thousands of businesses, applications, institutions, or users depend on infrastructure that is difficult to replace, the infrastructure becomes more than a service. It becomes a position of power.
And now we can see the architecture. At the top are the applications people recognize. Beneath them are software platforms. Beneath those are cloud systems. Beneath the cloud are data centers. Beneath the data centers are networks. Beneath the networks are cables, power systems, land, factories, and physical infrastructure. Every visible layer depends on another layer underneath it. This is how modern digital power is structured, not as one machine, but as a stack. And the deeper you go into the stack, the fewer people understand what they are actually looking at. So if you want to understand the future of artificial intelligence, do not only look at the model, look at what connects the model to the world. Follow the fiber, follow the data centers, follow the exchanges, follow the cables beneath the ocean, follow the companies building the networks, because information may be everywhere, but the infrastructure carrying that information is not, and that changes everything. The digital economy appears borderless, but its physical architecture has geography, it has bottlenecks, it has owners, it has dependencies, and wherever dependency concentrates, leverage follows. That is the hidden system. The internet is not simply a place where information moves, it is an infrastructure of power. And the next question is even more important. If networks connect the world, who controls the infrastructure at the center of those connections? ASUTSEN, architecting wealth, automating future.